Move right into the introduction to our first keynote. And your guys can put up his first slide on the screen too as well. Okay, good. Thank you. So the keynote this morning is 5G enabled Internet of Things. It'll be presented by Professor Sarigiannidis, which I'm sure I have butchered his name, from the Department of Electrical and Computer Engineering from the University of Western Macedonia in Greece. He's the director of the ICCE2025 Lab, co-founder of the first spin-off of the University of Western Macedonia's MetaMine Innovations, and a full professor in the Department of Electrical and Computer Engineering in the University of Western Macedonia in Greece. He received his Bachelor of Science and PhD degrees from the Aristotle University of Thessaloniki, Greece, in 2001 and 2007, respectively. He's published over 360 papers in international journals, conferences, and book chapters, including IEEE communication surveys and tutorials and IEEE transactions, IEEE Internet of Things, IEEE transactions on broadcasting, Systems Journal, Wireless Communications Magazine, and the Open Journal of Communication Society, the Journal of Lightwave Technology, IEEE Transactions in Industrial Informatics, IEEE Access and Computer Networks. He's received 6 Best Paper Awards and the IEEE SMC TCHS Research and Innovation Award in 23. He's been involved in several national, European, and international projects, coordinating and technically leading numerous national and European papers. He's an IEEE member and participates in the editorial boards of various journals like IEEE Transactions on Communications, IET Networks, International Journal of Communication Systems, and the International Journal of Information Society. So let us all welcome him to ICCE.
Good morning, all, everyone. Thank you so much for the introduction. Very glad to be here with you. Thank you for joining this session. I would be very glad today to present you the surface of the next generation Internet of Things today, by giving also emphasis on the connection aspects of this growing ecosystem. And I'm coming from Greece, from University of Western Macedonia. We're a very active lab. I have the honor to lead the lab here. And also we're very active in European and national funding projects, including Internet of Things, telecommunication, and artificial intelligence. So I will start with some acknowledgements of the European funding projects. Then I will give some background how we pave the way from IoT, conventional IoT, to the next generation IoT. Then I will focus on the pillars, the challenges, the trends of the NG-IoT. And then I will give you some examples of our contributions of how we could interplay with IoT with the 5G technology and the Open RAN. I will close the talk with some conclusions. So before starting, I would like to acknowledge the TERMINET project. It's a European one, Horizon Europe project, funded by the European Commission. It's recently ended successfully. So we had the chance here to talk, design, and implement the next generation reference model about what is the optimal, what is the good architecture to support the IoT ecosystem. And as you can see, the consortium, a lot of SMEs, industry, and academic partners participated in this project. And also I would like to acknowledge the NANCY one, which is an SNS, European funded project in the context of Horizon Europe as well. And here we try to, this is still ongoing, so we try to provide a novel open radio access network using a lot of trust system inside, like blockchain and coverage extenders. So we'll know that IoT is the main vehicle right now for implementing and realizing a lot of very useful verticals, use cases, and applications like smart cities, smart homes, wearables, agricultural cars, a lot of things. And in many cases, there is a debate about the future architecture. What is the next generation architecture of this ecosystem? And this is a quite indicative architecture. I will present it more later on, where we can see at the left the main horizontal verticals like the infrastructure, the platform, and the stakeholders, while three vertical layers, the access domain, the edge domain, and the core domain. And this is something that, it's the output of all the research and all the collaboration we had with major industry partners and academic partners from Europe in order to provide something concrete and able to cope with the new and the novel applications, especially the latency, those that have latency limitations. So more than 40 billion IoT devices are expected by 2030. And the connection protocols like the Bluetooth, Wi-Fi, cellular IoT will dominate the market, giving the evolution of new terms like the AI-enabled IoT, sustainable IoT, and edge computing. So the new surface needs a lot of novel things, an evolution, I could say here, in order to support more applications, more third parties, and new markets, like higher data rates, low latency, more security, privacy, and one of the most important things is trust. And I will try to explain why trust here is quite important, especially for the new and small enterprise. And here also we can see the evolution of and the forecast of the IoT analytics, where we are expecting more than 14% increase coming from the last year to 2030, no matter what is the connectivity type. So we have to prepare here the ground in order to support the playground of the IoT without restrictions on the connectivity protocols or the connectivity schemes. Right now, the main pillars of this next generation ecosystem could be summarized in 7 pillars. First is connectivity. Second is the data collection at the edge intelligence. The third is about the analytics, together with all the AI and machine learning evolution there. The fourth is the security. The fifth is the integration and the interoperability. The sixth has to do with the scalability and the interoperability issues. And the final one is something quite new of the last 5 years, the digital twins. So talking about connectivity, we have a lot of options right now, depending on what is the use case and the application is. So if we need range, but no guarantee on the delivery, we can go with the LoRaWAN. But if we need something more professional and quality of service, we have to go with cellular LoRaWAN. And of course, we have strict limitations on the data collection, where there is a need not only to collect data, but also to precisely collect, filter, and apply all the intelligence on the devices that collect data, of course, by using also customer experiences. And here, big data and all the methodology behind big data could play an important role. In any case, we need to provide accurate sensor readings and, of course, also to support real-time data collection, especially in critical infrastructure. Of course, real-time analytics is the brain of the ecosystem. It contains the data processing, it contains all the prediction analytics, all the data processing, the predictive analytics. And nowadays, this is part of the evolution of AI. And of course, we cannot talk right now about next generation IoT without analytics, without real-time analytics, and without artificial intelligence applications there. The security is another challenging issue where we have to deal with the old-fashioned, let's say, security threats coming from the old definition of sensor networks. And of course, to deal also and to address the new kind of security vulnerabilities, like the adversarial attacks on the AI or the malicious data injection on the AI training. So security is quite important, especially for the newcomers in the market to spend money, and extend their market, their enterprise. Still, integration interoperabilities, there are themes and issues that still remain unaddressable. So when we're talking about integration, we have to ensure that different manufacturers could support the same ecosystem, something quite difficult still due to the lack of standardization. And of course, all the trend here says that the users should exchange experiences, maybe data sets under some legal commitment, and of course, AI algorithms or AI models between them, so as to make all the intelligence better in a local level. Scalability is quite important. Without scalability, we cannot extend the enterprise, we cannot extend the market. So scalability is coming when we can extend and put more devices, let's say, or more features or more services without compatibility issues there. Digital twins is a very good, very flexible tool that gives us the opportunity for running what-if scenarios. So by interacting with a physical environment, the digital twin is an advanced, let's say, modern simulation environment where I can put many parameters and try to see what happens if I change this or that, so as to have even better results in the less time I have. Now, if I need to group the NG-IoT challenges right now, I could say 4 main directions. The first has to do with the intelligence challenges. The second about security and privacy. The third about connectivity and edge computing, and the fourth about management and virtualization. So when talking about intelligence challenges, we are talking about how the AI could provide optimization, energy efficient models at the edge, and of course, how we could also transfer all the intelligence from the cloud to the edge. Of course, an open question here is where is the edge? However, these questions could be easily resolved if we plan and design correctly the vertical and the application based on the user's needs. So it could be just a mobile phone or part of the data center, or even a simple individual device that could play the role of the edge node. About federated healthcare data systems, I will come back later on again, since federated learning and federated continuum seems to be a very flexible and powerful tool for covering many weaknesses of the current state of the IoT. So about security and privacy challenges, you can see the list of technologies, risks, and threats. The risks are gaining ground. More risks are added in the list day by day, and the same goes with the threats. Since the systems become complex, become more intelligent, and in some cases they become open, and more threats are coming there. There are a lot of technologies to confront and address today's risks, like the usual hacking or the financial fraud, or the denial of service and similar things. And on the other side, the technology should be carefully selected and put into place in the IoT ecosystem, since we are talking here also about, and we have to consider also constraints about limitation, energy consumption, and of course lifetime of the devices. However, in many cases we have simple solutions like that one, where we consider an energy-related IoT ecosystem, where we have a real device coming from a partner of the TERMINET project, the Schneider Electric. So what we did is to train an AI algorithm to react and respond like this real device by performing and forming a honeypot. So I could hide, for example, the real device by turning on a million of virtual machines that are the fake IoT devices, and of course to capture or to see it and to explore also the ongoing cyber attack tactics coming from outside. Another good example we did in TERMINET is to enhance the CM tool with mechanisms able to make correlations, make decisions, and to run at a level some AI correlation engine, where we could detect malicious traffic and anomalies as the CM gets all the traffic, detects the traffic, analyzes the traffic, and of course exports the traffic in many other agents. However, maybe the most powerful tool here is coming with the federated learning approach, where we have this opportunity to set up a privacy by design approach, where no data, no raw data are exchanged between the different agents. So we have the local clients, we have the global federated server, and we exchange only weights and AI features, no real data. So in this case, we could exploit many different features coming from different local places. So we do the local training, then the weights and the result of the AI training comes into the global node, and the global node has global knowledge, makes the integration and makes better decision that could be also transferred back to the local models. And we can see by having a lot of experiments here that the federated approach is also good in terms of performance. And based on all this knowledge, we made also a contribution to Flower, which is the biggest federated learning ecosystem there. Of course, as I said before, one of the most important trends here is to move the intelligence from the cloud to the edge. So we have to be able to make the computation at the edge, not in the cloud. Maybe the most advanced here, I mean, the good thing here has to do with the latency reduction. So if we have all the calculation, the training, and everything to go from the edge and back to the local nodes and the users, then the latency is reduced, and we could support, no matter what is the connectivity, more hard applications and sensitive applications. So the interplay between 5G and edge is really important, where we have to provide seamless integration of the 5G and of course the ongoing 6G technologies with the edge computing, so as to provide seamless connectivity requirements together with all the support of the connectivity to the edge nodes. Of course, this is still ongoing and a bit hard since no standardization protocols are existing there. However, the experiments and all the trends coming from the state of the art seems that shows that if we use, for example, AI for dynamic orchestration, by using stable connectivity, using 5G technology, for example, then we could have, by, for example, 27% better utilization of the existing resources, and of course, faster task completions, giving that a part of the network could be virtualized. Now, if we go forward to the management and the virtualization, this is something necessary at the time. We cannot talk about management without SDN architecture. So we decouple all the management, the decision of the physical devices, so we can make virtualizations. We can make better decision, better tasks to organize and plan better tasks for the physical devices in the infrastructure layer. By using quite mature controls and control schemes like the Open Daylight, the ONOS, and many others, based on the need of the use case and the vertical. Also, by introducing the P4 language process and all the discussion about the meta operating systems there, I could also better and more flexible utilize all the resources behind by having better decision of the control plane, and of course a more and wider use of protocols in the data plane. Of course, NFV is a unique and necessary part of all this discussion by providing and running software and virtual machines, containers or Dockers right now, allowing the designers and of course the players behind the market to support virtualization, better planning of the resources, and of course to define a reduced cost infrastructure in a better time. And this is also the guidelines coming from ICCE TSI as the NFV for the high-level architectural framework. Now I will move forward to 8 trends coming from all the experience we had from the project, especially from the TERMINET, and then I will forward to the 5G enable and all the choices we have about the connectivity. So the target right now is to move about 80% of the process from the cloud to the edge. And to this end, to doing that, we need meta operating systems like the P4 and all the family systems I mentioned before. And of course, we are talking about a new data economy right now, where we can exchange data, we can exchange experience, and of course, we can use or rent the infrastructure of another company or enterprise by having trust there. The roadmap of the AI, following, of course, all the evolution of the Gen AI and all the discussion about the ChatGPT and all the similar tools, is not only about texting, about a text performance or a text output. We need also to provide algorithms, machine learning algorithms, and all the training schemes to be fair and explainable. And this is a new concept that could also enhance and secure the trust of the newcomers and the small enterprises to be part of this. Since if we are able to provide guarantees that all the analytics, the decision making was trained in a fair way, and it could provide guarantees that's explainable and well designed, More and more enterprises will spend money and enter into this kind of business by, of course, enhancing at the same time all the data set production, since we need data in all the fashion on all the levels of this playground. Now, when talking about federated cloud continuum, we mean all the interaction between the cloud and the edge nodes regarding how a decentralized data processing system could be realized, and how we can collect data without harming any kind of loyalties or copyrights, and provide privacy by design, decentralized, well-performed ecosystem here. And again, as I said before, the federated concept seems quite strong to provide something like that. And beyond the better performance that presents compared to centralized solutions, here we could also exploit security features and to better secure the system with blockchain-enabled interactions between the nodes, and of course between any kind of stakeholder outside of the ecosystem. Another trend is not that we don't need silos of the past. We don't need silos anymore. What we need is open standards. We have to create. We have to push on open profiles, open interfaces, open solutions that could be also open for contributions by any kind of stakeholder, so as the customers and all the third parties to trust the system, to enter the system, and of course to create their own data, their own experience, and then to exchange the experience with other players there. Sustainability is also a key word here, since we are not, it's not enough to provide well performance, but also we have to provide in something novel, innovative, a good resources, efficient of resources, and to also to exploit renewable energy, to reduce cost, to reduce the footprint, and also to provide metrics about the energy performance beyond the other performance like latency and throughput, for example. For trust, we insist that a trusted IoT could attract external stakeholders here. The trust environment is necessary to encourage business, new business, and exchange of businesses. And of course, AI is designed in this way to support trust, and also to provide the necessary guarantees for making possible exchange between the stakeholders. One of the most challenging drawbacks here is the need for skilled, of course, professionals and citizens, since we have to populate all these technologies, the ecosystem, and the new markets with skilled professionals that could understand, that could interpret, and could also be part of all this playground, since all this evolution goes very fast, and it's quite difficult many times to to catch with that, and many stakeholders stay behind. A final trend has to do with the security by design concept, where the zero trust architecture seems to be a dominant technology that supports and ensures the verification and validation of the unique identity of all the software and hardware devices. And for doing that, we need also the collaboration of the manufacturer, so as to provide all the validation roadmap from the construction to the final usage. Together with that, we need also hardware-level encryption algorithm, and of course, AI-powered threat detection in order to be able to respond to security threats in real time coming from systems that lack of zero trust architecture. Now, before going to the radio access network evolution, I would like to give you a very small part of two verticals, especially coming from TERMINET, and I would be also happy to present some results here about two quite difficult, let's say, two quite tough businesses outside. So here we have Doug. Doug runs a business in Sweden where he supports a simulation environment for medical personnel. This environment is located in the Karolinska University in Stockholm, Sweden. So Doug tries here to enable a group of medical personnel that uses at the same time the same environment remotely. So you can see here the haptics and how Doug follows the rules in order to be trained in a real-time application. And what we addressed here is the high latency of the haptics when Doug, moves his hands from the one part to the other.
Team training in surgery and other real-time critical tasks.
And this lack of synchronization, as you can understand here, is something that could not enable this kind of applications, since the latency here, in order to be doable, is quite low. And of course, this is only an example of the capabilities of remote training in a simulation environment using concurrent and parallel group of people using haptics controllers. And I will go a bit on
exact finger movements when
here, for example, you can see two people, their hands as they communicate each other, and they try to collaborate for undertaking a task. And if we go at the last part here, you can see how the federated learning, which is already installed in two edge nodes in Sweden, could make all this recognition of gesture locally by using federated learning and pre-trained models, as I mentioned before. And here you can see also the
federated learning component
probability of success when Doug here applies some gestures in order for the system and the simulation to recognize it in real time and in such a way to save time for exchanging data between the cloud and the real application. And I would like also to give you a small piece of this research output about the smart farming application using augmented reality glasses. Another application that is coming and becomes even more expandable by using AR and VR glasses. However, as you know, and you can understand here, the requirements of having these glasses and of course the connectivity of these glasses, especially in rural areas, are a real challenge. However,
wearing the TERMINET smart glasses in order to monitor
provide important information in the AR glasses in real time.
I'm currently seeing that the levels of methane and carbon dioxide are normal.
Metrics,
and now
without
I'm going to continue
everyday tasks in the part. And of course, the connectivity here goes up to the GEneRation
conditions of this table are becoming unfavorable for the animals.
Federated
I need to open the stable air circulation system in order to recycle there
to do more
barn and lower
to create
the carbon dioxide levels
for the farmer,
a circulation system,
and also
create
pulseras.
good
As you can
decisions.
see, we are currently in the
And
second stable of the
another
farm in
application here
Kozani.
of the glasses is
This is the stable that we
to
keep
read,
the animals
special
that are in
information,
production.
again without
And as you can see,
disturbing the everyday
I'm wearing the TERMINET
business
smart
of,
glasses to
farmers
check
here.
in real time the conditions of the barn and of the animals, such as the temperature, humidity, and the carbon dioxide levels. By using the AR glasses, I can perform a very quick and easy check of the animals. I can do this by scanning the QR code that the animals have on their ear tags. Let me demonstrate how easy it is. I can hold the animal using my two hands, and without the help of anyone else, I can check the requested data. By just saying scan QR, I can see general information about the animal. I can see now the average milk production, and I can also see the days that this animal is in production. Also, I can check more information about the...
All right, so more and more information is becoming able for the end user by using all this kind of technology, and open the way and open the ground for new businesses in this demanding, and challenging IoT devices like the AR VR glasses. Now, all of these things should be realized by having stable connectivity. So we have to also examine what is happening with the cellular connection here. And in NANCY, in the other project I mentioned before, we try to see how we can set up a trusted environment, and also to extend the capabilities of O-RAN. So by O-RAN, we mean that RRH and BBU are decoupled, which means that the physical devices and all the signal processing components are managed differently. So this opens also the way to scale up the infrastructure, and also to be connected with different physical channels and media. And this kind of technology offers improved performance, and of course offers the trends that I mentioned before, that provides open, flexible, and software-driven RAN, like the guidelines of ETSI in this very recent conference in the last November 2024. So the direction here is to create open interfaces, to create open source software, and of course to extend all these challenges by create the opportunity for third parties and newcomers to enter and use and extend this kind of business. And here you can see a testbed we created in the lab by extending the coverage and also installing in this micro-operator blockchain components, in order for the main operator to be in line and trusted with the micro-operator. So any kind of IoT enterprise, small or medium, could come into this architecture, put their applications, their algorithms, or use part of it by having open interfaces without restrictions, and of course without dependencies with the manufacturers. What we run here as an early experiment is to see if we can detect threats that could be inserted by an intermediate node or by end user, since the architecture is open. And very indicatively, we examined, we concluded that by inserting a malicious traffic like SYNFLOOD or TCP scan or SYNSCAN or whatever, we could, of course, by using well-known datasets here, we could detect the malicious traffic, even though the architecture is a custom one. And beyond that, we provide explainability for transparency for the end users and the stakeholders here, where we explain the results, how they finally defined. And of course, we can see easily here, and anyone could see that, for example, the feature flow packet IPDU length var, which is a parameter which by which the AI algorithm was trained, is the feature that has more significant impact on the final results. So by concluding the talk about 5G-enabled next generation IoT, we can say that the market is huge and still growing. And of course, there is still room for improving especially the latency restricted NG-IoT, like the haptics, the robots, the AR, VR, and the UAVs, in order to open further the market and to include also more newcomers. However, scalability, sustainability, and connectivity remains still unaddressed, and we have to work a lot for maybe to collaborate more with the existing situation and state, especially about the manufacturers. O-RAN seems a good solution for providing open interfaces and extend and facilitate the IoT to be more open. And finally, trust is quite important. And we have also to ensure that all the tools like the blockchain or the explainability AI in order to make it trustable and open to any kind of small or medium business that could join and extend and make more innovations given the existing infrastructure. So I would like to thank you for your attention, and I will be very glad to discuss and answer your questions. Thank you.
Oh my goodness. That's a lot of information to take in a short period of time. So we do have some time for questions, and we actually have a small amount of time for questions. So short questions and short answers, please.
Why not normalize all connectivity to packets like we do with the internet, and not worry about whether it's 5G radio, whether it's LoRa or whatever, and and then deal with latency as a constraint? For example, we handle 2-hour latency with the Mars rover just fine, and voice over IP has latency transparently too. So why do we have to worry about all these things rather than have the application adapt?
Yeah, that's a good point, and we have also to consider where the applications is launched and installed. So in many cases, when talking about small and medium enterprises, we have businesses without coverage or without good signal. Yeah, but it's not so easy in any kind of area, and we have also to count with the population of its antenna, and the density of the data coverage there, and also another very important thing is the propagation delay between the actual business and the remote user from the distance. Yeah.
Yeah, so we are running out of time, but